quiet. All right. Anyway, so again, we're doing 8-2 equations part 2. They're going to get a little more complicated. So it's like today we're going to have to be factoring. So this is already on your notes. But the directions say here to solve. So in order to solve, notice I have the squared. That means it's a quadratic. So to solve a quadratic, and notice I have 3 terms. So this is a trinomial. So for a trinomial, we had to first check if there's a GCF. And then we go to like the blank plus blank and blank times blank. You guys remember doing that? Yes? No? Maybe so? Okay. So remember they have to add up to the b value and multiply to a times c. So what is my b value in this example? -4. And then my a times c, that would be 1 times -5. So this has to multiply to -5. So what two numbers add up to -4 and multiply to -5? -5 and a +1. Good. Because the 4 is negative, you want the bigger number to be negative. So you want the 5 negative. And then if you remember, we did this split into 2 binomials equals 0. And then you take the first term, that's an x squared, and then you split it in half. So then that becomes an x and an x. And then you take the other two numbers, a -5 and the 1 that we got, and that goes in the second blank. -5 and a +1. And then to solve for x, basically now you make each piece equal to 0. So we would do x minus 5 equals 0. And solve for x, we would add 5 to each side, so that'll give us an x value of what? 5. And then do the same thing with this. X plus 1 equals 0. Subtract 1 to each side, and that gives us our -1. But basically what we're doing is just switching the sign in the parentheses. So I got an x minus 5, so the solution is going to be x equals 5. You just switch the sign. A +1, my solution is going to be -1. Okay? So those are my two solutions. Today we're going to see the square root equations. And we're going to end up, because to get rid of the square root, you have to square both sides. We're going to end up with the quadratic, like an x squared equation. So we're going to have to be factoring today. All right, so we have our concept slide here. And it says we have a radical equation contains a variable within a radical or variable raised to non-integer rational exponent. So we saw this slide the first lesson. It's the same slide. It's just a reminder that our variable has to be under the square root, or our variable has to be raised to a fractional exponent. That's the same as we saw on lesson 1. It's the same slide. Non-examples, we can see it has to have an equal sign for it to be an equation. And you need to have the variable inside the square root in order for it to be radical. So for the non-examples here, I can see this one has no equal sign. This one, the x does not have a radical. And then this, no equation sign. So it's not a radical equation. All right, we also saw this slide for lesson 1. It says radical equations can have extraneous solutions. And so if you remember, extraneous solutions are solutions that fail to make the left side and the right side of the equation equal. And we saw that yesterday, like 2 equals 5. 2 does not equal 5, so then whatever you plugged in would be extraneous. We haven't seen this second part where like solutions that are imaginary or create imaginary values. when you plug in would also be extraneous. We haven't seen an example like that yet, but we will see them in this lesson, but we might not get to it today. It might have to end up being until Monday, but it'll be like the square root of a -2 or square root of -4. Those produce imaginary values. So if you remember like I don't know if you remember, if you even know, I don't know if you've been taught this, but like imaginary values are the square root of a -1. So like this is really split into like the square root of 4 times the square root of -1. And so the square root of 4 is 2, and the square root of -1 is I. So this I are called imaginary numbers. They do not exist. Well, I shouldn't say that. I should say they're not real, is what I'm trying to say. They're imaginary because there's no possible way for me to get a negative by multiplying the same number by itself twice. They're either two positives makes it positive, two negatives makes it positive. So there's no way that I can take a number and multiply by itself and get a negative value. So that's why they're called imaginary. But again, we're not going to see that probably today. We'll probably see it until Monday. All right, then we also have this concept slide. So steps to solve the radical equation. We saw the first step is to isolate the radical expression. But basically that means we are going to undo, let me color coordinate this. Isolate the radical expression basically means we undo operations outside the square root. That's the first thing we do. So PEMDAS in reverse. First get rid of addition and subtraction, then multiplication and division. Then once we have the radical by itself, we're going to raise both sides of the equation to the appropriate power. That'll get rid of the square root. So like basically that means we're going to undo the square root by squaring both sides. And then our third step, which we didn't really do anything with this on the first lesson, is to solve the resulting equation. But basically that means undo operations that were inside the square root. So first we'll see an equation. We'll have stuff outside the square root. You got to get rid of all the stuff on the outside. Then you get rid of the square root, and then you'd be left with whatever was on inside the square root. So then you undo operations in that order for PEMDAS in the reverse. Okay? And then at the end, if you remember, we're checking for extraneous solution. You'd have to plug it into the original. So plug into the original equation and see if it's extraneous or not. Okay? But as a reminder, we're doing please excuse my dear Aunt Sally in reverse. So first we get rid of addition and subtraction, then multiplication and division. We don't really see like exponents and parentheses in this lesson, but that's the order you get rid of them. So let's look at an example for today. It's kind of like in the middle of the sentence for some reason. So let me just rewrite it. We have the square root of 3x minus 2 with this minus 5 on the outside equals 0. Okay, so our first step again is to get whatever's attached to the square root. We want to get that by itself, so get rid of anything extra. So I have that -5 left over. That's not on the inside of the square root, so we have to get rid of that -5 by doing what? Adding 5. We add 5 to both sides. That gives us the square root of 3x minus 2 equals, that 5 minus 5 cancels, and we get 0 plus 5 gets us 5. All right, now I have the square root by itself. So what did we do yesterday to get rid of the square root? Square both sides. We're going to take this, square it, and the 5 squared. Then the square root would cancel out the squared. We're left with the 3x minus 2 equals, what's 5 squared? 5 times 5 is 25. Good. So notice now I have extra stuff now. Now my step 3 is to get this x by itself now. That was what was left inside the square root. So now I do PEMDAS in reverse again. So I have to get rid of addition and subtraction first, and then multiplication and division. So do I get rid of the 3 or the negative 2 first? The negative 2 goes away first because it's addition and subtraction. So we would have to add 2 to both sides. We get 3x equals 25 plus 2 is 27. And then that's 3 times x. So what do we do to get rid of the 3? Divide by 3 to both sides. And I get a x equals, what's 27 divided by 3? 9. Okay, that's my possible solution. I don't know if it's valid or extraneous, so then we have to go plug it in. So we're going to check now. And remember to check, you plug it into the original equation. So I have the square root of 3 times x, but what did we get for x? 9. Minus 2 with the negative 5 on the outside. And we're checking to see if that equals 0. But remember, you do not do anything to the 0. Leave the 0 alone. Simplify the left as much as possible, and then check to see if it equals 0. Okay? So this is going to be the square root of, what's 3 times 9? 27. Minus 2. So what's 27 minus 2? 25. And square root of 25 gets us 5. So 5 minus 5 is 0. Does that equal 0? Yes. That means x equals 9 is valid. And that is my final solution, is x equals 9. Okay. So again, it's not that much different than yesterday. It's just that yesterday we only had an x under the square root. So when we squared it, this ended up just being an x. But now we have stuff inside the square root, and then we do inverse operations to solve for the x. Okay? That's the only difference really in this example. So let's go ahead and look now at our next example. But again, this is kind of, I don't know why they put them like in the middle of the sentence, but let me rewrite it. We have a 2 on the outside, square root of 3x plus 4 with the plus 8 on the outside equal to 0. All right, so remember, we're doing PEMDAS in reverse. We're doing, please excuse my dear Aunt Sally, in reverse. So first get rid of addition and subtraction, and then multiplication and division. So I'm trying to get this by itself. So I have to get rid of anything extra. I have to get rid of the 2 and the 8. But what goes first? The 8, because we're adding and subtracting. So first we subtract 8 to both sides. Those cancel. I get a 2 times the square root of 3x plus 4 equals negative 8. And again, I'm still trying to get this by itself. So now I have to get rid of the 2 by doing what? Dividing. That's 2 times. So the inverse would be to divide both sides by 2. So the 2's cancel. We get the square root of 3x plus 4 equals, what's negative 8 divided by 2? Negative 4. And then I have to get rid of the square root now. So what did we do yesterday again to get rid of the square root? Square both sides. So square root cancels the squared. I get a 3x plus 4 equals a negative 4 squared. That's negative 4 times negative 4, which is what? Positive 16. Alright, that got rid of the square root. Now I'm left with what was on the inside of the square root. So on the inside of the square root, I had the 3x plus 4. So now I do PEMDAS in reverse again to get the x by itself. So please excuse my dear Aunt Sally. In the reverse, first get rid of addition and subtraction, then multiplication and division. So I have to get the x by itself, I have the extra 3 and the 4 right there. So what goes first? The plus 4 needs to go away first. So I need to subtract 4. Oops, I thought I was on the pen. We have to subtract 4 to each side. And then we get 3x equals, what's 16 minus 4? 12, yes. And then we divide by 3. That gives us x equals what? What's 12 divided by 3? 4. That's my possible solution. So now I have to go check it. We're going to go plug it in. We need to check by plugging it into the original equation. So I have 2 times the square root of 3 times what's my x value? 4. And then we got the plus 4. Our check, oh no, we had the plus 8 still on the outside. And we're checking to see if that equals 0. But we leave the 0 alone. Do not do anything to the 0. That's going to be 2 times the square root of what? What's 3 times 4? 12. And 12 plus 4 is 16. And what is the square root of 16? What number multiplied by itself gets you 16? 4. Thank you. And 2 times 4 gives us 8. And 8 plus 8 was 8 plus 8. And 16. Does that equal 0? No. That means that this is not going to be a solution. This is extraneous. So because it's extraneous, remember we say no solution. No solution. All right, we're going to have you guys practice the next example. You're going to do it by yourself this time and see if you guys can do it. Okay, so moving on, we're going to now do something with this one. So let's copy it on your paper. We have the 2 plus the square root of x plus 10 equals x on the other side. right, so go ahead and talk to your partner. What do you guys notice is different in this example than all the previous ones that we've done? What do you notice is different? What did you guys say? What's different here? Anybody notice? Anything different?
We have 2 x's.
2 x's, right? I have an x right here, and I have an x on the other side of the equal. And so when we square both sides, to get rid of the square root, we're going to end up with the x squared. So it's going to be quadratic. And so because it's quadratic, we're going to end up having to factor. So let's go ahead and try this one. Our goal again is to get this by itself. What's the only thing that's extra on that side? The 2. How would I get rid of the 2?
-2.
Subtract, because it's an adding, right? Good. So we subtract 2 to both sides. Those cancel the 2. And then we're left with the square root of x plus 10 equals an x minus 2. All right, so now I need to get rid of the square root. We need to square both sides. Square both sides. Therefore, the square root cancels out the squared. I'm left with x plus 10 equals. What happens here? Remember, what does that squared mean? I can't distribute this time because it's subtraction. We distribute when it's multiplication. But, let me do it off on the side over here. What is a 5 squared? What does that mean? But how do you get 25? 5 times 5, right? You take the same number, multiply by itself, so it's the same number twice, right? So the same thing. This twice. So really I'm doing x minus 2 times x minus 2. I have to multiply by itself twice, okay? Multiply by itself twice. And so when we get there, really what that means is you got to take the x and distribute this way, okay? So I am going to copy the x plus 10 down. X plus 10 equals, what's x times x? X squared. And x times negative 2? Negative 2x. And then I do the same thing now with the negative 2. I have to now distribute negative 2 times x is what? Negative 2x. And negative 2 times negative 2 is positive 4. Now I need to combine like terms. So I have this x plus 10 equals. I have these two like terms right here, negative 2x and a minus 2x. So that's a x squared minus 4x with a plus 4. Again, that negative 2x and a negative 2x became a negative 4x. And now I have a quadratic. So a quadratic, remember, in order to solve, I need to factor. But before I can factor, this has to equal 0. This side has to equal 0 in order for me to factor it. So I need to get rid of this x plus 10. We need to subtract x to make the x a 0. And then we subtract 10 so that this whole side is going to be 0. But whatever we do to one side, we do to the other. So now subtract x and subtract 10. My x minus x cancels. And 10 minus 10 is 0. I need that side to be 0. Equals. Now bring down the x squared. A negative 4x minus another x is going to be a negative 5x, and 4 minus 10 is -6. All right, now this is kind of like what we did for prior knowledge. What did we do to solve for this? Quadratic, so check for GCF. Do I have a GCF? No, so then what do we go after? Blank plus blank, blank times blank. What do the two numbers have to add up to? -5 and multiplied to -6. So what two numbers is that going to be? Go ahead and talk to your partner. What do you think those two numbers are going to be? Lefties, go ahead and share first. If you're sitting on the left side, you're lefty. So lefty, tell your partner, what are those two numbers? All right, what are my two numbers here? -6 and 1. Thank you. -6 and a +1. So now I have the 0 equals. I'm going to take this trinomial, split it. Again, take the x squared, splits in half. So now I have an x and an x. And then my two numbers go in the second blank. I have the -6 and a +1. And then solve for x for each of those. This x minus 6 is going to be a x equals what? +6. And this one right here is going to be x equals -1. We just switch the sign. Because really what we're doing is making it equal to 0 and solve for x. So we add 6 and subtract 1. That's where we get a +6 and a -1. But notice now I got two possible solutions. So I have to check both of them, okay? We have to check both of them because we don't know. So it could be one of them is extraneous, the other is valid. It could be both are extraneous, or it could be both are valid. So we don't know what's going to happen, so you got to check both of them, okay? So we got to check by plugging it into the original. I'm going to first check for x equals 6. So let's go plug it in. We have a 2 plus the square root of my x value is 6. So I'm plugging in a 6 plus 10. And I'm checking to see if that equals x, but x again is a 6. So because I had two x's, I have to plug in 6 to both x's. This gives me a 2 plus, what's 6 plus 10? 16. And the square root of 16 is 4. 2 plus 4 is 6. Does that equal 6? Yes, so this one is valid. For now, let's check the -1. Check x equals -1. Well, it's the same thing. We're going to plug it in to the original equation. We have the 2 plus the square root of, my x is -1 this time, plus 10 equals my x value, which is -1. So 2 plus the square root of, what's 10 minus 1? 9. And the square root of 9 is 3. And what's 2 plus 3? 5. Does that equal -1? No. This is -1 ends up being extraneous. So my only solution is x equals 6, not the -1, because -1 is extraneous. Okay. All right, so I know that's like a lot of work for this problem, but Again, I don't think it's too difficult. It's just a lot of work. But we do have to end up distributing here and then simplifying the quadratic. And then because it's a quadratic, we need to make this side equal to 0 so that we can factor. So distribute, simplify, make this equal to 0, and then factor. And because we get two solutions, we have to check both of them. Okay? So I'm going to have you guys go ahead and try the next one and see if you guys can do it.